All right, let's go ahead and start today's lesson. This is the beginning of our last unit. Today we're going to talk about inscribed angles. Before now we've talked about central angles. The central angle is where the vertex is at the center of the circle. Inscribed angles, instead of the vertex being at the center of the circle, the vertex is on the circle. So the formal definition is an inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords of the circle. So in this picture down here, angle KHD, that's an inscribed angle. Its vertex is on the circle. An intercepted arc is made of the endpoints that lie on the sides of the inscribed angle and all the points on the circle in between them. So when we're talking about the intercepted arc here, we're talking about this part here. So if you are a football fan, it's like, okay, this is the defender's arms and he has intercepted this arc. It has to be in between his two arms. Although some of them can make quite spectacular circus catches and the like. Generally speaking, when you catch a football, you want one hand on one side and one hand on the other side. So occasionally you'll see something that says a chord subtends instead of it being the intercepted arc. It means the same thing. It's kind of an older usage. It just doesn't get used as much in textbooks anymore, but you may see that from time to time. I usually just say it's the intercepted arc. So here's the deal. Unlike the central angle, where the central angle was equal in measure to the arc, an inscribed angle's measure is half of the arc. Real quick, let me show you why. You do not need to draw this, but please follow along. I'll draw a circle over here. And to make it simple, we'll draw something like this. So Carter, give me what you think the measure of this arc might be, just so everyone knows I'm not cheating. 25, all right. So if that angle is 25, then anybody, what's the measure of this central angle? 25. Not particularly difficult, right? And then how can we find the measure of this angle right here that's next to the 25? Yeah, subtract that from 180. So 180 minus 25, it's 155. Now, I'm going to switch colors. Let's look at this inscribed angle. And say we want to find the measure of that. You're like, well, I have this theorem, but let's say we didn't have that theorem yet, right? What kind of a triangle is this triangle right here? It's obtuse. What is it also, because these two sides are the same length? It's isosceles. So to find the measure of both of these angles, we could take 180 minus 155, which is 25, and cut it in half. It's 12.5. And notice the last thing we did was we cut 25 in half. This theorem allows you to go straight to that rather than having to draw in extra pieces and find extra angles and draw in a triangle and all that. It just tells you that if you have this inscribed angle, the measure of the angle is half of the arc. This says 12.5. Sorry, it got a little messy. So if you have an inscribed angle, its measure is half the measure of its intercepted arc. So in this diagram up here, this angle is half the measure of arc KD. All right, we're going to actually do this problem in the opposite order that it's been asked here. Let's find the measure of angle DAE. So from D to A to E, its vertex is on the circle and its sides are made of chords. So that's an inscribed angle. Its measure is just going to be half of the arc that's intercepted. So this is half of 78, which is 39 degrees. Now for this next one, it wants me to find the measure of arc ADE. Hey guys. Field day's done?
Yeah.
So if I want the measure of arc ADE, that's from A all the way around here to E. That arc is intercepted by this angle down here at the bottom. Again, think of that as, two arms reaching out. The arc that's inside them is the intercepted arc. So the measure of arc ADE is going to be twice as much as the angle, since the angle is half as much as the arc. So this will be 2 times 125 would be 250 degrees. So when the vertex of the angle is on the circle and its sides are made of chords, the angle will be half of the size of the arc that it cuts off or it intercepts. So here, 39 is half of the 78. On the other one, this arc, 125 needs to be half of that arc, so that arc has to be 250. The arc has to be twice as much, because we're going in the opposite direction. Let's take a look at this example. We're trying to find the measure of angle EDF, and I know in terms of x, it's 2x plus 3, so I need to be able to solve for x. I need to write an equation and solve for x. Well, the measure of angle D is half the measure of arc EF. Because if we follow D out, it hits the circle here at E, and it hits the circle here at F. So it's half the measure of this arc. It's an inscribed angle. Its vertex is on the circle, and its sides are both chords. All right, well, that I can't solve that. Over here, notice the measure of angle G. If I follow it out, it also hits the circle at E and at F. So its inscribed angle, or its intercepted arc, is also EF. So if both of those things are true, we know the measure of angle D is equal to the measure of angle G. They both intercept this same arc, so they've got to be the same size. So that's just 2x plus 3 is equal to 7x minus 25. Subtract the 2x and we get 5x. Add the 25 and we get 28. Divide and we get that x is 5.6. And the measure of angle EDF, which is what they asked us for, is going to be 2 times 5.6 plus 3. It's 11.2 plus 3 is 14.2 degrees. Any questions about that example? All right, the next two things that we have are both a result of this first theorem. You may or may not remember that's called a corollary. It's not important that you know that these are corollaries, but they come as a direct result of this first theorem. The first one says that an inscribed angle is subtended by a semicircle if and only if the angle is a right angle. So here, if we know that angle y is a right angle, then we know that this arc that connects the ends, it subtends it, the intercepted arc, has got to be 180. Or, if we know that that arc's measure is 180, we know that this angle is 90. This actually comes up in problems pretty regularly, believe it or not, but they almost never tell you that this is 180. They almost always have that this is a diameter. But if that's a diameter, then this is a semicircle, so its measure is 180. So then this angle has to be a right angle. It's actually, and you don't need to draw this, but I'm going to. If you want to draw a right angle, if you can start with a circle and draw in a diameter, it'd be nice if I drew something at least a little bit straight. That's close. Then I can pick any point I want to on either side. Let's say I pick this point. It's going to make a right angle every single time. No matter what point I pick out up there, that angle is going to be a right angle. And once you have a right angle, you've got a right triangle, and you have opportunities for special right triangles like 30, 60, 90, or Pythagorean theorem, or even trigonometry. I don't think we have any that we use trigonometry on this unit, though. Not a fan? All right. The last theorem, again, is a direct result of that first one, is that if a quadrilateral is inscribed in a circle, that means when you say the quadrilateral is inscribed in a circle, what that means is all the vertices, you might want to add this, of the quadrilateral are on the circle. Then its opposite angles are supplementary. It's important that it's the opposite angles. The most common mistake on this is people will say it's the consecutive angles. It's got to be the ones across from each other. So here, angle J and angle M are supplementary, and angle A and angle E are supplementary. Every single time, no matter what. Just a real quick of why. Again, you don't need to draw this, but let's say I start with this angle, angle J. It intercepts the arc from here all the way around to here, right? and that angle is half the measure of this enormous arc. But we don't know the measure of the arc yet. In fact, I'm not ever going to know the measure of the arc on this. And then if I start with angle M, which is over here, it hits the arc, the circle at E and A, so it's going to be all of this. Well, what does this green arc and this red arc add up to? Try again. 360. And the angles are each half of their arc. So what do the two angles have to add up to? If the two arcs add up to 360, and each angle is half of the arc, 180. That's why these two angles are supplementary. So you will have a problem like this on your next quiz and on the test. And believe it or not, every year I have people who miss this. Okay? It's not hard, but you do have to know this theorem. So let's work this out. They want me to find the measures of all the angles in this quadrilateral. Notice it is inscribed in the circle. Every vertex lies on the circle. So I know that the opposite angles are supplementary. I could try to start with T and M, but I don't know anything about angle M, so that's probably not the best place to start. Start with something that you know about. So D and L, these two angles are going to be supplementary. So 3B plus 25 plus 6B plus 20 is equal to 180. It's got to be the opposite angles, the ones that are across from one another, that are going to be supplementary, not the ones next to each other. So group the like terms. That's 9B plus 45 is 180. Subtracting, we get 9B is 135. Dividing, we get that B is 15. Now we can start finding the angles. I'm going to start by finding D and L. The measure of angle D will be 3 times 15 plus 25, which is 70. The measure of angle L will be 6 times 15 plus 20, which is 110. What do these two angles add up to? 180, which is what we said all along. This is a good place to double check yourself. Make sure you didn't make a mistake in the algebra. Now I'm going to find the measure of angle T. It's 10 times 15 minus 69. See, it's 150 minus 69 is 81 degrees. So the measure of angle M, what do I know about angles T and M? They're supplementary. So since T and M are supplementary, the measure of angle M will be 180 minus 81 will be 99 degrees. Okay, questions about that? All right, you actually have a pretty good chunk of time to go ahead and get started on your assignment, which is in your book.